HiveMQ Data Hub is an integrated policy and data transformation engine that validates, enforces, and manipulates data in motion to ensure data integrity and quality across your MQTT deployment. It solves several issues that can occur when data is transferred from device to cloud in industrial IoT environments. In this video, we will show you how it works. Our example shows a factory with several machines on the shop floor. All of them use MQTT to send and receive data. There are 2 new machines and 1 old legacy machine. All 3 machines publish data to the HiveMQ broker in the middle of this deployment. Additional extensions can be used to connect this data to other services like databases. From the broker, data is transferred to data consumers in the cloud. Here, a database, which is subscribed to the broker and stores all data for further consumption. This could be for monitoring or further analysis, or like in this example, to be stored in the data lake. Now let's have a look at the data itself. New machine 1 sends 5 metrics in JSON format: machine ID, timestamp, status, temperature, and pressure. All the data runs through the broker and is transferred to the database. When all 5 key metrics exist in this JSON object, the data is accepted and finally ingested to the database. For new machine 2, the process is more or less identical. The old machine is an exception. It also sends values for machine ID, timestamp, and status, but 2 key metrics are missing: temperature and pressure. The broker still forwards the data. But with 2 essential key metrics missing, the data becomes invalid for the database. It is rejected and dropped, and the database will not process any data from old machine 1. This results in 3 issues. First, there's a blank spot on our shop floor, because 1 machine sends data that cannot be processed. Second, the entire effort of transferring data from the old device to the database is inefficient. It is wasting resources without any outcome. But the machine continues to publish data because 3, there is no feedback about the 2 missing essential metrics which make the JSON data invalid. Now HiveMQ Data Hub comes into play. Data Hub is located in between the publishing devices and the HiveMQ broker and comes with 2 important components: schemas and data policies. Let's look at schemas first. Schemas are simply a specification of the format in which data should be organized. In our example, the 5 key metrics are defined as mandatory. By definition, the JSON data coming from new machine 1 is regarded as valid, while data from old machine 1 is considered invalid. It does not match the schema. But the definition of a schema alone is not sufficient for validation. The second component of Data Hub, data policy, is also required. Let's take a look at the control center. In the HiveMQ control center, we navigate to schema in the Data Hub section. First step is creating a new schema and defining a schema ID. We call it machine schema. Second, select a schema type, in our case JSON. Step 3 is adding a schema definition. Now the schema is available for HiveMQ, but we still need something to enforce the schema. This is done by creating a data policy. Step 4, create a new data policy and apply an ID. We choose drop publishes, because when published data is identified as invalid, it should be dropped. Choose our previously created schema as schema validator. In the last step, we are going to address the issue of missing feedback. Under action on failure, we define a specific reaction to failure events. Choose a function to drop MQTT messages. Now enter a meaningful message into the text area labeled with reason string. This defines the feedback message MQTT clients get. The first part is an arbitrary string. The second part interpolates the validation result. Now let's see Data Hub in action. New machine 1 is sending data in the correct format, which is ingested by the database. The same happens when new machine 2 publishes data. Now we look at the old machine and see what has changed. Unlike before, this old machine is not able to send any data to the database. It can't bypass HiveMQ Data Hub. Instead, old machine 1 receives a negative pubEgg from HiveMQ, which contains the reason string we defined before in the data policy. In addition, a detailed validation result is attached to the message, which informs the MQTT client about the parameters that were missing and caused the message drop. Hopefully this demo has shed some light on the benefits of HiveMQ Data Hub. It solves all of the problems we identified in the beginning. We can now identify clients sending invalid data and no longer have blank spots. We get detailed feedback on what causes a failure. Data Hub drops the message early in the data supply chain. It no longer causes resource-intensive validation checks. If you would like to learn more about HiveMQ and MQTT, subscribe to our channel. Thank you.